Okay, we are going to talk a little bit about doing net ionic equations. We'll begin with using these results that are found on your double displacement and solubility lab. We're going to look particularly where we have sodium sulfide reacting with lead nitrate. And you see when you react those, you get a precipitate. So we want to write the molecular equation for this. So we're going to begin with NaS. And actually, if you look, it would be Na2S, because Na is a 1 plus and S is a 2 minus. So we have Na2S, and that will be an aqueous solution, because all of these are aqueous solutions. And we're reacting that with lead. In this case, it's lead 2 nitrate, because we know that nitrate is a -1. So therefore, this has to be a 2 plus, because there's two of them. So PbNO3 2. PbNO3 2. And again, this is another aqueous solution. That reacts in a double displacement reaction where the sodium goes with the nitrate and the lead goes with the sulfate. So by writing these, we will make our products. So we have NaNO3, and we know that this is a +1 and this is a -1, so that balances out like it is, plus PbS. In this case, it's a 2 plus and a 2 minus, so that compound balances. Now we look at our overall equation, and we see that I have 2 NAs and 2 NO3s, but only one of each down in the products. So therefore, that will be a 2. And now my reaction is balanced. But I'm missing states of matter, you may notice, for here, for NO3 and for the PBs. Now, if you were reading along with this lab, you would have seen that they told you that if ever you have a product that has a sodium in it or a nitrate, those two will always be soluble. Any compound, any salt that has both NO3, excuse me, not both, either NO3 or Na, either of those will make it soluble. So if I go back to our reaction here, since this has both Na and NO3, it will certainly be soluble. So this would be an aqueous solution. But if I look again, remember it made a precipitate, right? It told us, hey, this makes a precipitate. So one of my products must be a precipitate. Therefore, it is the lead. And again, this would be any compound with Na or NO3 in it is soluble. So this is just our basic molecular equation. You know this. We've worked on this all year. The difference is now I am making you know what this is. I won't tell you that, like I did in the last test, that the lead product that contains lead becomes a precipitate. I won't say it this time. I'm assuming you remember Na or NO3 makes it into an aqueous solution. Okay, so here's our molecular equation. We would now like to please write an ionic equation. And the ionic equation is simply where I take all of the aqueous solutions and I break them into their pieces. So therefore, I have Na, becomes a positive, plus S, which is a 2 minus. But because I have two of them, I'm going to make this 2 NAs, not a subscript 2. I don't want that, because I'm not trying to balance these two ions. I'm just showing you that I have 2 of them in my compound. So that will react with a Pb 2 plus NO3, which is a 1 minus. And again, I have 2 of those, because again, if you see, I've got my 2 there. Those guys will produce in my reaction, again, aqueous solution of NaNO3, sodium nitrate. So it becomes Na positive plus NO3 minus. But again, notice the 2. So I have to have 2 for each of these guys, plus my precipitate, my PbSO4, excuse me, PbS, because this is my precipitate, lead sulfide, that stays together. And that is the key part, that the aqueous, they break apart into their ions, and the precipitate, it stays together. So I have my lovely Ionic equation. Last, I have my net Ionic equation. Very simply, I take my Ionic equation, and anything that is on both the reactants and the products, I cross out. So since my sodium is in both of these, I forget about them. Since my nitrates, my two nitrates, are in both of these, I forget about them. So therefore, all I have left is my sulfur, my lead, and my lead sulfide. So in my net ionic equation, I simply write those pieces that are left. My S2 minus plus my Pb2 plus produces Pbs. This is my net ionic equation. It's like the Cliff Notes. My molecular equation gives me the whole story. It tells me everything that's happening in this reaction. Whereas my net ionic equation is just simply the Cliff Notes. So it just tells me the important pieces that are producing that precipitate. Theoretically, you would not necessarily have to do an ionic equation to produce a net ionic equation. If I go back to my results, let's say instead we're going to look over here at zinc nitrate working with sodium chromate. So we know that my zinc is going to work with my chromate, and my NO3 is going to go with my sodium because they're an exchange reaction, double displacement. We know this is aqueous, so this has to be my precipitate, zinc chromate. In this case, it's zinc, which is a 2 plus, is going with chromate, that is a 2 minus. So theoretically, if I know that zinc, CrO4, zinc chromate is my insoluble product that I produce, well, what are the ions that make that up? Well, it's zinc as a 2 plus CrO4, a 2 minus. So this would be my net ionic equation. So you don't have to do the ionic equation in the middle. You would certainly have to produce a molecular equation. And we kind of did that just in our minds here as we balanced sodium nitrate and zinc chromate together. Hopefully that's helpful for you. I'd be glad to answer any further questions if you need.